Hello everyone. In this video, I'm going to talk about physical quantities. I'm going to talk about scalars, vectors, tensors, and I'm going to talk about the misconceptions that are very common misconceptions among students. Right? I'm not going into the detail of everything. I'm not going to tell you what different kinds of vectors are, but I'm going to tell you about the misconceptions, basic misconceptions that many students have. Right? So let's just start it. फर्स्ट थिंग फर्स्ट व्हाट इज अ फिजिकल क्वांटिटी फिजिकल क्वांटिटी क्या होती है राइट तो एग्जांपल के थ्रू समझते हैं इसको लेट्स से यू गो टू अ प्लेस जहां पर आपको एक पत्थर मिला एक रॉक मिली राइट नाउ यू वांट टू डिफाइन दैट रॉक यू वांट टू टेल अ पर्सन टेल योर फ्रेंड अबाउट दैट रॉक तो आप कैसे बताओगे आप ऐसा तो है नहीं कि उस पत्थर को उठा के लेके जाओ एंड यू विल शो दैट ओ सी आई फाउंड अ पत्थर आई फाउंड अ रॉक नो यू आर नॉट गोइंग टू डू दैट if you want to okay you can do that but you should not what you are going to do is you are going to define some physical quantities like उस पत्थर की हाइट क्या थी उस पत्थर की ब्रेथ क्या थी डेप्थ क्या थी या उसकी डेंसिटी क्या थी या उसका मास क्या था so all these quantities which were required by you to define the properties the physical properties of that rock are physical quantities now physical quantities can be anything like time ho gaya distance ho gayi these are what these are physical quantities which are required to quantify the measurement of a property of a material मटेरियल की कोई भी प्रॉपर्टी हो सकती है उसकी प्रॉपर्टी उसकी हाइट है उसकी डेंसिटी है दीज आर द प्रॉपर्टीज इनको क्वांटिफाई करने के लिए वी नीड सर्टेन फिजिकल क्वांटिटीज लाइक मास डेंसिटी टाइम everything else so physical quantities are actually the property of a material or a system which can be quantified right which can be quantified using a measurement हाइट को मेजर कर लिया हाइट इज अ फिजिकल क्वांटिटी क्या है हाइट इट्स अ प्रॉपर्टी ऑफ द मटेरियल करेक्ट so physical quantities are property of a material or a system that can be quantified by the measurement right so this is physical quantity now physical quantities को define करने के लिए physical quantities physical quantities are something which can be quantified right now to quantify that we use tensors so केवल tensors but physical quantities तो हमारी scalar vector tensor तीनों हो सकती है right no it's not like that it's all the physical quantities are defined using tensors how let's see that अब आपने फिजिकल क्वांटिटीज डिफाइन कर दी उन फिजिकल क्वांटिटीज की कुछ प्रॉपर्टीज हैं राइट उन प्रॉपर्टीज को डिफाइन करने के लिए वी नीड सम मैथमेटिक्स एंड दैट मैथमेटिकल ऑब्जेक्ट इज टेंसर अब स्केलर और वेक्टर क्या है स्केलर और वेक्टर एक्चुअली आर टेंसर्स इटसेल्फ व्हाट आर टेंसर्स टेंसर्स की डेफिनेशन क्या है बेसिक टेंसर्स आर सिंपली द मैथमेटिकल ऑब्जेक्ट्स which can be used to describe the physical properties like कि उसकी height है कितनी height is a physical quantity but to define it mathematically we need a quantity like distance how much meters it is 10 meters 20 meters 15 meters time is a physical quantity but to quantify it we need mathematics we need a mathematical object that is seconds 15 seconds 20 seconds we define them and then we use it right so all the quantities that are defined in that the properties are defined are tensors mathematics is tensors so अब टेंसर्स में हमने देखा कि हम किसी भी फिजिकल क्वांटिटी को एक्चुअली बेसिकली हमने जो पढ़ा है वो ये पढ़ा है दैट physical quantities are defined as in three categories we can divide it scalars then vectors and then tensors right but actually what I am trying to tell you is it's only tensors tensors are further categorized into three or more categories right zero order tensor is scalar first order tensor is vector and second or higher degree we just call it tensors for 11th and 12th standard we just categorize it as tensor it can be of third order fourth order fifth order I will give you some examples but let's write it down and see what it's okay so here we go physical quantities and tensors Tensors are mathematical objects that can be used to describe the physical properties of quantities, physical quantities, right? Now, tensors are categorized or divided into multiple categories. It can be a zero order tensor, first order tensor, and so on, second order, third order, and so on, correct? And so on. Zero order tensors are known as scalars. अब scalars को define करने के लिए what we need is only the magnitude. Now there is a misconception about magnitude also. Magnitude actually is scalar value, sorry, numerical value multiplied by its unit. आप केवल 5 या 10 बोलकर ये नहीं कह सकते that it's the magnitude. No, 5 or 10 is not the magnitude. Magnitude is 5 meter, 10 meters, 10 seconds, 15 seconds. You have to multiply it by its unit also. Correct? Example, 5 meters, 30 seconds, 10 ampere, and so on. Correct? So zero order tensors are scalars. First order tensors are vectors. In vectors, we need to define magnitude as well as direction. We'll talk about vectors in a little bit more, right? We have to define magnitude as well as direction for vectors. So we need I cap, j cap, and k cap, as we already know, correct? What are second order tensors? Second order tensors की requirement हमें तब पड़ती है when we need a vector, we need x component of some quantity depends on the xyz quantity components of another quantity. क्या मतलब है? मतलब जब हमारे पास कोई फिजिकल क्वांटिटी ऐसी आती है, फॉर एग्जांपल हमारे पास इलेक्ट्रिकल कंडक्टिविटी. नाउ आई नो दैट most of the 11th standard students won't be able to understand it. Most of the 12th standard students will also not be able to understand it, so I'm not going to go into the detail. But let's say we take an example of, let's say, graphite, correct? What happens in graphite, there is a flow of electrons in one particular direction. They prefer current flow of current in one direction. So electric field के x, y and z component पर there will be conductivity of one direction will depend. So conductivity is going to be defined of one direction will be defined using vectors of all three directions, and that will become a second order tensor, right? So electrical conductivity is a second order tensor. Other examples second order tensor के second rank tensor के हो जाते हैं हमारे पास electrical susceptibility, electrical susceptibility, and then again we have thermal conductivity, stress, strain, right? All these are second order tensors. Then we have third order tensors, fourth order tensors. थोड़ा बहुत आपने इनके बारे में quantities के बारे में शायद पढ़ा हो, third order and fourth order. Let me give you some examples of third order and fourth order also. For example, let's say third order की बात करें. Third order is piezoelectricity. Piezoelectricity or and you can say also polarization. Polarization is third order. फोर्थ ऑर्डर की बात करें तो फोर्थ ऑर्डर का एग्जांपल आप ले सकते हैं स्टिफनेस. Stiffness is a fourth order tensor. So we have second order, third order, fourth order, fifth order. As we go on increasing the order, it will be difficult for us to physically imagine that. It is going to be difficult, but they are defined. So first thing is the misconception that I want to clear is all physical quantities are defined by tensors, mathematically defined by tensors. Why? Because mathematically mathematical part, mathematical objects that to define the physical properties is tensor, right? They can be of multiple orders, many orders, zero, first, second, third, fourth, so on. Zero order tensors, scalars, first order tensors are vectors, second order, third order are, we are not concerned about them, right? Now, there is another concept, there is another mistake that that most of the students do is while defining the vectors. What are vectors? So vectors को generally जब हम define करते हैं, so we do write about three properties. First, they should have magnitude. Magnitude means numerical value plus unit, correct? They should have direction. Well, x, y, z, they should be quantified with directions, right? Along with the direction, and they should follow the vector law of addition, parallelogram law, triangle law that we already know, that if this is a vector, this is, let's say, b vector, then their sum can be written as by completing the parallelogram, and this will be resultant vector r, correct? Or you can shift b vector and then again r vector will be the resultant vector. इसको आप दो तरीके से देखते हैं, parallelogram law या फिर triangle law of addition. But what we don't talk about is there is a fourth property, and the fourth property, can you guess what the fourth property is? Yeah, and the fourth property is they should also follow the commutative law of addition. Commutative law of addition. What's that? Commutative law is if a vector plus b vector is some resultant vector, then b vector plus a vector should also give you the same result. अब दिमाग में आता है कि सर, how is it possible that this should always be valid, right? This isn't. For one quantity, there is a quantity जो हम 11th में ही पढ़ते हैं in circular motion, which does not obey the law of commutative law, right? And that's why it doesn't become a vector. Can you guess what it is? Yeah, exactly. If you can, then it is angular displacement. A considerable amount of angular displacement does not follow the commutative law, and theta 1 plus theta 2 does not is not equal to theta 2 plus theta 1. So angular displacement does not become a vector quantity, but d theta 1 plus d theta 2 is equal to d theta 1, d theta 2 plus d theta 1. The small angular displacement is a vector quantity, but large angular displacement is not a vector quantity. Let me prove it to you using uh, an example. So we have a copy here, right? Now I'm going to rotate it twice from 90 degree, and we'll see the orientations, right? So theta 1 towards me, and then theta 2 towards you. Again, theta 1 and theta 2. Observe the orientation. Theta 1 and theta 2. Correct. Now, instead of rotating it towards me first, let me rotate it towards you. That theta 2 towards you, and then theta 1. Totally different orientation. Theta 1 plus theta 2, theta 1, theta 2 plus theta 1. We get two different orientations, right? But अगर मैं इसको बहुत छोटा एंगल घुमाता हूँ, that is d theta 1, d theta 2, d theta 1 towards me, d theta 2 towards you, or d theta 2 towards you, d theta 1 towards me. Again, it comes into the same orientation. So we can say that theta 1 plus theta 2 and theta 2 plus theta 1 is not same. That means theta angular displacement is not a vector quantity. But when we talk about small angular displacement, d theta 1, d theta 2, or d theta 2 plus d theta 1, then it is a vector quantity. So vector quantities should fulfill four conditions. There should be four conditions that a vector quantity should fulfill. First, magnitude, direction. Third is vector law of addition, and is the fourth one is the commutative law of addition. All the four quantities should be full. All the four laws, four conditions should be fulfilled for vector addition. And we see that in circular motion chapter that angular displacement is not a vector quantity if we are going to consider large angular displacements, right? So we discussed in this video what are physical quantities, what are tensors, zero order, first order, second order, third order, and so on. All the physical quantities are defined by tensors, which are used to define the physical properties of those physical quantities. Then we talked about the conditions that are required for vectors and the example which actually does not follow the commutative law of addition and therefore is not a vector quantity, that is angular displacement. So that's it for this video. See you in the next video. If you have any doubts, make sure that you write them down in the comment box and I'll answer them. Okay, bye bye.